Dear students, in this online, in this video presentation, we'll see the problem, mathematical model, numerical problem, and an unsolved problem. We'll discuss on various topics of machine learning algorithm. In those algorithms, we'll see the linear regression with single variable, multiple variable. Then in the next sessions, we'll see polynomial regression, logistic regression. We'll see all this with a brief idea, the mathematical model, and a numerical solution for this. Okay. Now first we'll see the linear regression. This is derived. This is taken from. This is taken from the line equation, that is y equal to mx plus c. Y equal to mx plus c, where y is slope and c is intercept, the constant. Here little variation in that. Y equal to a naught plus a1 x. That is a basic equation, where x is the independent attribute, y is the dependent attribute. A naught and a1 are the constants. A naught and a1 are the constant. A naught is intercept, which represent the bias, and a1 is the slope of the line. These two are called, a naught and a1 are called regression coefficients. As you can see in this equation, y equal to a naught plus a1 x plus e. That e is the error introduced. How to get that error? We know that from the equation we'll get the value, observed value, and actual value. Actual value given in the data set, observed value from the equation. Many cases these values need not be same, may not be same. So that is called error. So E is represented as the difference between observed output and the actual output. This difference is called error. This error is mutually independent with the same distributions, such as normal distribution with the zero mean and constant variables. You can see that in the diagram. There is a line which is a plot of x versus y. There are some points which are on the line. When these points are on the line, the difference will be zero. You can say that are best fit. There are some points which are above the line. There are some points which are below the line. That line indicates actual output, and the difference between that x value, that coordinate, that point, and perpendicular to that on the line. On the line is called error. It's called error. Okay. Now our main intention is to reduce this error. In general, if there are n data points, that is expressed in terms of y. That is, for the first data point, y1 equal to a naught plus a1 x1 plus e1, y2 equal to a naught plus a1 x2 plus e2, like that yn equal to a naught plus a1 xn plus en, where ei is the error, xi is the x coordinate, yi is the y observed value, a naught is the constant, a1 is the intercept and the slope. So that E can be found by subtracting a naught plus a1 x from y, that is ei equal to yi minus a naught plus a1 xi. This is the equation for error. Now our main goal is to find the best fit line. That means most of the points should lie on the line, but it is not possible. But we can try by minimizing the error. Error equation is E equal to summation of all errors sigma ei, where I equal to 1 to n. You can substitute the value of E, that is sigma I equal to 1 to n yi minus a naught plus a1 xi. The sum of all these errors we have to minimize. Okay, these errors may be positive or may be negative. So what we'll do, we'll take the absolute value, that is E equal to sigma I equal to 1 to n ei. This is the absolute value, sum of absolute value of these errors. If you are keeping that sign, then you square this, that is E equal to sigma equal to 1 to n ei whole square. Ei whole square. So our main intention is to reduce the errors, as the line equation depends on two coefficients, regression coefficients a1 and a0, that can be expressed as j of a1 a0 equal to I equal to 1 to n yi minus that line equation f of xi, the whole square, that is sigma equal to 1 to n yi minus a0 plus a1 x1 whole square. So this is the main thing which is modeled for linear regression and minimize the error, the minimum function there for the error. Okay. In that equation we saw a0 and a1. That a1 and a0 can be computed as follows. Okay. Product of xy, that mean, minus x bar y bar divided by the mean of square of x and square of mean. A1 equal to x y whole bar minus x bar into y bar divided by xi whole square x bar. Similarly, a0 can be found as a0 equal to y bar minus a1 x bar. This is the mathematical model for linear regression. Now we'll take one problem how to solve that. This is a sample data given for 5 weeks and sales observed in these 5 weeks in terms of thousands. The first week 1.2, second week 1.8, third week 2.6, fourth week 3.2, fifth week 3.8. We have to get all the ingredients, that is x square, x into y, all those you have to get, x bar, y bar. Okay, now we'll take one by one. Sum of x, the mean value. Sum is 5 plus 4 plus 3 plus 2 plus 1 is 15 divided by 5. Mean is 3, that is x bar. The same way y bar can be computed by adding all the things divided by 5, that is 2.52. X square. Square the value of x, get its mean. So 25, 16, 9, 4, 1, altogether 55 divided by 5, 11. The product of x and y, 1.2 into 1, 1.8 into 2, 2.6 into 3, 3.2 into 4, 3.8 into 5, altogether 44.4 divided by 5. Altogether the mean is 8.8. Substitute them, we will get a1. a1 equal to x y bar, the mean of product of x and y, minus x bar into y bar divided by x square bar minus x bar whole square, that is 0.66. And A naught can be computed as y bar minus a1 into x bar, that is 2.52 y bar minus 0.66 into 3, that is 0.54. So that is the equation that we get, that we got y equal to 0.54 plus 0.66 into x. If x value is given, we can easily find out the y, that is the predicted value. Many points lies on the line. The first bit, some point may not be on the line. So when these points are not on the line, our intention is to reduce the errors. So y hat equal to 0.54 plus 0.66 into x. Same can be solved if the values are in the form of matrix. Regression, linear regression in the matrix form. Y is expressed as x into a1 plus a0 plus error. So this is expressed in the form of matrix. There are n observed values, y1 to yn. Okay. The first column should be 1. The second column is that x value independent variable, and a0 and a1 are the two coefficients plus errors e1 to en. The thing that you have to note here, the a can be computed. A gives a0 and a1. A can be computed as x transpose into x its inverse into x transpose into y. This equation you have to remember. A, the matrix a0 and a1 are the two rows that we will get. X transpose into x its inverse into x transpose into y. So step by step you have to solve. First is the given value of x. X will be, x is given here. The equation x is given 1, 2, 3, 4. Y is given 1, 3, 4, 8. So x transpose is 1, 2, 3, 4. Y transpose is 1, 3, 4, 8. So you have to write it in this form. Okay. The first column is 1, 1, 1, 1 because there are 4 observations. Second column, the x value 1, 2, 3, 4. The first column can be used for setting bias. Here we have assumed bias value as 1. Okay. Then y is also given 1, 3, 4, 8. X and y are represented in the form of matrix. Now transpose of x and x are multiplied. Transpose of x and x are multiplied. This is the transpose of x. Change column to row, row to column. Multiply that with x. You will get the result. That you have to inverse. We should know how to inverse a given matrix. After inversing, you multiply that with x transpose. You will get matrix that you have to multiply with y. This resultant matrix is 2 cross 4 and y is 1 cross 4 cross 1. So all will get 2 cross 1 matrix. The first is intercept and the second is slope. First is that minus 1.5 is a0 and 2.2 is a slope. So everything will be in the form of matrix. So this is about single variable. If there are multiple variables, in the previous case x only the one dependent variable and y is the independent variable. X is the independent variable and y is the dependent variable. Suppose there are multiple independent variables are given. The method is same, only the number of variables changes. So y is expressed as, it is expressed in terms of x1 and x2. That is a0 plus a1 x1 plus a2 x2. Y equal to, it's a function of x1 and x2. a0 plus a1 x1 a2 x2, like that it goes. Plus epsilon. Epsilon is the error. Let us take one example. X and x2, x1 and x2 are given and y also given. Here there are two independent variable, product of one sales of second product, and output of weekly sales in thousands. 1, 2, 3, 4, the observations of x1, 4, 5, 82 is observations of x2, corresponding value 1, 6, 8, 12. The process is same. Here, additional column will come. In the previous case, we had only one column. The first is the bias 1, 1, 1, 1. Second is x1, third is x2. Y is same, and rest of the things are same. Here we will get the a value. How many variables are there? That many number of a1, a2 like that. A hat equal to x transpose into x inverse x transpose into y. X transpose into x, its inverse x transpose y. Polynomial. The next topic is polynomial regression. If the relationship between the independent variable and the dependent variable is not linear, in case of linear regression, the relationship is linear, as we saw that line is straight line. But in case of polynomial regression, it is not linear, it is non-linear. Depends on the degree of the polynomial. The problem of this non-linearity can be solved by two methods. One is the transformation method. The second one is the polynomial regression. Here we are concentrating on polynomial regression. Suppose equation 2 degree 2 equation y equal to a0 plus a1x plus a2x2 is quadratic form because the degree is 2. In this equation, y equal to a0 plus a1x a2x square plus a3x cube is cubic equation. Degree is 3. Highest exponent of x is 3, so degree is 3. In all this, whatever the case, our main intention is to reduce the error. Error can be computed as usual, y actual minus y detected, predicted. But this is required. This is the matrix. This one you should remember. That is n, the degree of the polynomial, sigma of xi, sigma of x square, then sigma x square, sigma x cube, then sigma x square, sigma x cube, sigma x to the power of 4, a0, a1, a2, because there are degree 2. The same way, sigma y, sigma xy, sigma x square y. It is easy to remember, n x square. Then in the next row, second column, third column, and the one more will come. In the third row, second and third column, then one more will come. N xi, x square sigma, sigma x square, sigma x cube, sigma x square, sigma x cube, sigma x square. So this is the thing. So after that, if this is from this equation, you can compute A easily. That is, we know we can get all these value with the easy computation, that x value, its inverse into B. This is the given sample data, x, y, x 1, 2, 3, 4, 1, 4, 9, 15. I said that it is non-linear. There is no linearity between x and y. So you have to compute all the necessary things. Sigma x, sigma y, sigma xy, sigma x square y, sigma x cube, sigma x 4, like that. Substitute all the values. Degree 4 will come now. Okay, degree 4. Then sigma x square 30, sigma x 10, sigma x square 30, sigma x 300, sigma x square, sigma x cube, sigma x 4 354. In the same way, sigma y xy x square y. This is y, 29 is the y, sigma y. Second one is x y, third one is x square y, like that it goes. So A can be computed as X matrix, this matrix inverse into this one. So we'll get answer. Try this in your free time. So y is expressed as A naught minus 0.95 plus 9.95 into x, 0.75 into x square. You substitute the value of x, you get y. Logistic regression. So this is used mainly for the binary classifier, which works by predicting the probability of categorical values. In general, it takes one or more features, that is x, and predicts y. Probability is given as p of x equal to a plus a1 x. So here, the odd probability is the probability of an event that occurs out of probability of a non-event, that is p divided by occurring at any particular event, say p minus other one, 1 minus p. So logistic can be formulated mathematically as log of p of x divided by 1 minus p of x. To get p of x, you can use this equation, that is exponential of a naught plus a1 x divided by 1 plus exponential of a naught plus a1 x. Okay. This can also be written like this: p of x equal to 1 over 1 plus exponential of minus a naught minus a1 x. If this y value is 1, we can say that probability is more than 50%. If it is 0, no, binary classification can be used. There is a small problem given a naught and a1. a1 naught is 1, a1 is 8, and x is also given. So compute z value. So y can be computed as, first compute z value, a naught plus a1 into x, 1 plus 8 into 6 to the 481, compute it. Y equal to 1 over 1 plus exponential of minus 41 as per the equation. 1 divided by 2.271, that is 0.44. This value is less than 0.5, so this is not selected, rejected. Okay. Less than 0.5, set to be no, false. If more than or equal to 0.5, set to be true. Okay. So these are the problems that I'm having, like on linear regression single variable, linear regression multiple variable, polynomial regression, and logistic regression. I'm going to share all these problems and solve all these by day end. Thank you and have a nice time.